Imagine waking up each day feeling like reality is slipping further from your grasp, your mind filling with voices only you can hear, visions only you can see. This is the world experienced by millions of people with schizophrenia, a condition that often isolates and deeply challenges those affected as well as their loved ones. Growing up, I saw the struggle up close in a family member whose undiagnosed schizoaffective disorder left them adrift in a reality many of us could hardly comprehend. Their journey shaped my own understanding of the complexities of schizophrenia and made me realize how much more there is to learn about the causes and treatments. Schizophrenia affects over 200 million people globally. It's more than a disorder of the mind. It disrupts lives with symptoms that include vivid hallucinations, delusions, social withdrawal, and cognitive difficulties. In this talk, I will be exploring the interplay of genetic and environmental factors that contribute to schizophrenia, shedding light on how biological and life circumstances together influence its development, and what that means for how we should view and treat it. Schizophrenia is one of the most irritable psychiatric disorders, with irritability estimates reaching as high as 80%. That means genetics plays a significant role in determining who might develop schizophrenia, though the story is far from simple. The disorder has a complex genetic architecture with hundreds, perhaps thousands of genes contributing to an individual's risks. There are, of course, rare variants of a gene that contribute to it. However, it is more commonly influenced by many common genetic variants, each of which individually contribute to a small effect but together weave a large tapestry of vulnerability, with each gene acting as its own thread. In recent years, advancements in genomics have made it possible to study these genetic contributions on a broader scale. GWAS have identified thousands of genetic variations associated with schizophrenia, while PRS offer a method to gauge an individual's genetic predisposition to the disorder. By examining the complex interplay of genetic factors, scientists are gaining unprecedented insights into who might be increased risk for schizophrenia, opening doors to earlier interventions and personalized approaches to mental health care. And when we're thinking about mental health and disorders of schizophrenia, we often focus on the genetics, but genes alone do not tell us the whole story. Imagine our genetic makeup is like the blueprint, setting the stage for who we might become. Environmental factors, on the other hand, are like the forces shaping that blueprint, influencing our mental health from the earliest moments all the way through adulthood. Timing is crucial when it comes to these environmental exposures. From prenatal development to adolescence, different life stages bring unique vulnerabilities, like infections, cannabis use, maternal distress. Studies have shown these specific environmental factors affect those earlier in life due to the rapid brain development occurring at the time. So that's why those specific factors, especially in earlier stages in life, have such significance in what the risks are in later in life developing schizophrenia. In essence, while our genes are providing a foundation, our life experiences and environment work together to shape who we are. This complex interplay of genetics and environment emphasizes that mental health is not set in stone, but is instead the result of a dynamic and ongoing process. And by understanding these environmental factors, we open up new pathways for early intervention and hopefully a more compassionate understanding of mental health. It's so easy to think of genetics and environments as two separate forces, but they're more like partners in crime that influence mental health. It's the essence of a gene-environment interactions, a dynamic interplay where both genetic makeup and environmental exposure shape the risk of developing schizophrenia. In the end, these gene-environmental interactions shift the way we think about schizophrenia. It's not just about genetics or the environment in isolation. It's about how these forces combine, creating a complex web of risk that reflects our unique genetic predispositions. But where does that lead us? It leads us to mice. Using animal models, scientists were able to put the symptoms of schizophrenia onto animals and then test out various genes, such as the DISC1 gene or the NRG1 gene, to help develop more understanding and a deeper understanding of how specific environmental factors are affected in contribution to genetic factors.
But what does this information lead us to? Well, it leads us to mice. Scientists were able to use animal models to provide insights to the complex dance between schizophrenia's genetic and environmental factors. In studying schizophrenia, scientists cannot easily replicate core features like hallucinations or delusions in animals, so they took a different approach. Rather than trying to mimic every symptom, they focus on creating models that allow us to examine brain circuitry and cellular changes that schizophrenia may involve. These models let us peek into the invisible mechanics of how genetic vulnerabilities and environmental factors combine to shape brain development and behavior. One model they used was of the DISC1 gene, which is linked to brain development and schizophrenia. In a study, researchers exposed young mice to the DISC1 gene to a virus-like immune stimulant. The mix of the DISC1 gene and the immune and the immune activation suggests environmental factors might use this mix at specific times to influence schizophrenia. Similar with the NRG1 gene, which plays a role in brain and heart development, researchers combined adolescent stress and a partial deletion of NRG1 in mice. The gene deletion alone caused minor changes in behavior, but when combined with stress, mice showed significant memory and mood-related issues. But what now? Well, think about it. If we could identify someone's genetic predisposition to schizophrenia early in life, we might be able to predict and mitigate the risk of before symptoms even appear. This is where the future is headed. Moving forward, we have the opportunity to rethink how we approach schizophrenia. Instead of waiting for symptoms to manifest, we could focus on early identification. But let's end with a thought to carry with you. Could future breakthroughs in genetics and environmental science allow us to reduce the burden of schizophrenia and reshape mental health treatment? If we keep exploring those intersections of genes and environment, the future may be brighter and more hopeful than we ever imagined.